thank you very much everyone for being here, and thank you for having us. My name is Yves Maout, and I will present with Boaz here why and what it takes to take DuckDB in the cloud. So first, the first slide about us, the traditional one. So when I started preparing the slide a little bit before the train, because Boaz wanted to do that last minute, I was like, hey, how should I introduce yourself? And I was like, well, I don't talk about myself, so I guess I will introduce a little bit of it. I will say something about myself. I first started my career working for BNP Paribas. I was a French bank. Before joining a startup about 9 years ago called Stoic, doing a lot of data feeding and essentially trying to reinvent the next generation spreadsheet, working with big data, which led me to meet Mark and Hannes and working with DuckDB, and I loved it so much that I wanted to be more involved and joined MotherDuck last year. And just even if he doesn't want to be talked about here, Boaz joined us from the way of Elastic, where he was in charge of the distributed parts, and later on became the technical leader of the cloud platform. So very quickly, and yeah, had fun with GPT generation image. So very quickly about MotherDuck. So we were founded, we created the company last year in June. We have a very tight relationship with DuckDB Labs. We initially started the company with 11 veterans from the industry. The CEO of the company is Jordan Tigani, who is one of the founding engineers of Query, and a lot of other people. Like I think we have, I don't know where they are, right over there. We have Mehdi as well, who joined us, and another folk that you will meet later with like the little like duck pads on the head. Cool, and we also backed by industry-leading venture capital fund. So why would we do that in the first place? Why take this in-process, in-memory database to the cloud? At first, it sounds like a little bit like incompatible. First, the realization is that, well, it's nice. Most people don't have that much data, and much people work with data sets that are actually not like petabyte, like a huge company, but like more something around like 100 gigabyte size. And and the query that they extract from that is actually even much smaller, like a few order of magnitude smaller. So Jordan noticed that 90% of the query that are processed actually address around 100 megabytes of data, and that you can bring back from the cloud to your local laptop. So essentially, we see that the scaling of the compute is much smaller than the scaling of the storage that you put in the cloud. And another realization is that small scenarios are underserved by big company, where they focus on requests geared towards like terabytes or bigger. Also, why do we want to use the cloud is to reduce, like if you do your processing and most of your data scanning back in the cloud, you don't pay for all the egress costs. On that, I will leave the floor to Boaz to tell us how we're doing that.
Thanks, Yves. So just to echo the last presenters, we actually do this through an extension mechanism. So all the crazy stuff you're hopefully going to see, that's all done through the very accommodating API that you get to do many things. And I can only stress out what was said, that asterisk is pretty deep, a long way there. So I think the first thing to point out when you put DuckDB in the cloud, that they're actually not running in the cloud. Okay, so this is key to our proposition. Yves talked about how the data is small, it fits in memory, your laptops run just fine. That's probably what you've been doing with DuckDB so far, and there's no reason to walk away from that because it actually does give you quite a lot. Most importantly, it's the fastest way to play around with your data. Right? The data is locally, there's no network overhead. In the extreme case of Wasm, it's actually in the browser, and that's what we want to maintain as much as possible. Okay, so we will try to run everything that we can locally on our laptop, and everything that's not on your laptop will be aggressively try to push it to your laptop so you can get this awesome experience. Okay, and by the way, maybe I missed it while doing something on my phone, but this talk is aspirational at parts. Okay, so we will show you a demo at the end of where we are right now, but there's a lot of things that we just did not build yet and are on our own to look at and research. So the main purpose of the talk is to give you an idea of what it takes. So looking forward for the discussions. By the way, my style is if you have a question, just raise your hand and ask a question. It makes it nice. Okay, so going back to the slide, we talk about interactivity and local speed, execution speed. This is really great, but then also it really is also an enabler to doing second level functionality that's also really hard, and the things that call on the slide are autocomplete, right? So if you have access to the data, you can see what tables you have, you can see maybe some logical min-max operator, whatever, you can do fancy thing that's really only local at the speeds of a local interaction. If you try to do it with a cloud backend, that's prohibitive. Or you can do something like the cool demo like Falcon, if you've seen it, running on DuckDB in a browser, where you have instant charting of your data, and you can zoom in and out and play with it. It's all there. So resorting, all these things are very nice locally. And then finally, this little asterisk, which we often don't really find sexy, but it is there. Sometimes your data is bound to the laptop. You just don't want to put it in the cloud. It's just mine, and that can be, of course, regulation, but it can also be because I just generated from some file that I have something, and it's a bit of a hassle to upload it, download it, and play it. It's just there. That's it. So how do we go about to make sure that you can run as much as possible in the cloud? Locally. We came up with something that's not really new. It turns out someone told me insider that it's been done in the 80s, so good for you. You're very innovative, which is really cool because then I got to read some interesting papers and look at how we can improve things, and also admire how further we got from the 80s, where they do this testing on the databases with a lot of data. 6,000 tuples was lots of data examples. Okay, but for our case, here's a simple query, 3 table T, S, and R, and all we do is join on the shared ID. And if you look at how this is done in DuckDB, you get this plan where you have T and S being first reduced and then hashed into a hash table, and then all the data from R is streamed through that and being reduced and enriched based on T and S. Okay. This is a mostly in parallelism paper, this chart, and we're going to use this chart as a basis for explaining. So before we start, we need to kind of assume some things about the data. So just for the sake of discussion, assume that T is a local table, and S and R are tables that are data that is stored in the cloud. So far, so. So the first thing that makes sense is if you want to join S and R, right, and both of them are in the cloud, then maybe we should do this entire first join in the cloud rather than do what I just said, which is first build T, then build S into a hash table, then run out through them. Okay? So that's exactly what we do. We go and identify these pieces and say, hey, if S and R are T and they form a subtree together, go and do this in the cloud. Again, in the cloud we have a DuckDB, same as the local DuckDB, so we can do this. And we have the first join. Now, what to do with T? Any suggestions, ideas? So that really depends. So the first thing that makes sense, okay, the first projection, well, right now it's a select star, so it's not really interesting, but say we would only select a few fields, and that kind of makes sense to do it locally because the data is locally, extract what you need, and that's it. And from this point on, depends, okay? So assume that the join of SNR is really small, like after we join the whole thing, we turn up with little data, and T is huge, okay? T is on my laptop, can easily have 20 gigabytes of a Parquet file lying there. It doesn't really make sense to send this 20 gigabytes up to the cloud to do the join and bring it back, right? So in that case, probably better off downloading the first join and then merging it with T. However, the reverse can also be possible, right? That SNR and join is huge and T is small, so it's actually quite convenient if T is just say 30 lines to upload T into the cloud and then reduce all the data even more and only download the result, which is then, in this case, at most 30 lines. So that might make sense too. And that's part of what we need to do, and that's why we have an extension that looks at data, try to collect statistics, decide how to plan this, and Yves will demo that later. Okay? You will. So that we do all this planning. So think about it: one DuckDB, and it runs a plan the way it runs a plan. Then you have one DuckDB in the cloud and one DuckDB in the cloud, and we try to break it apart and merge it in arbitrary ways. So this will actually have working now, and Yves will show it. But I wanted to show you that this is the plan when you start from scratch and you just look at the tables and you want to make this decision. But it also may very well be that you did something before you did this. And if you take, again, a very simple scenario where we say, hey, I looked at SNL and I joined them and I looked at what I got and I figured, well, wait a second, it's not everything I need. I actually have this T thing and I want to merge it into the result, and then I get what I actually need, which I think is totally feasible, but that's how it goes. In that case, in the first query, again, both of them are in the cloud, so it makes, there is really little option than to join them in cloud and download everything to your laptop, and then you have the results, okay? But then, I'm a human, I'm personally very slow compared to my laptop, and I'm sitting there, I'm looking at the results, and I'm looking like this, and looking at that, and decide whether it's good to me. In the meantime, we can take the opportunity and say, hey, let's just pull all the data, rather than the first time result of I just look, let's just keep on pulling, because the user's not doing anything, and internet is typically not, you just always subscribe it and it's already, and we can cache the entire right side of the tree, okay? And if we cache all of that, that means that now, if we look at the case where, this was actually in a previous case where SNR was large and T was very small, just 20 lines, it made sense to upload T to do the join in the cloud, right? But now, actually everything is local. So if you look at this plan, the right side is already cached, fully local, T is fully local, so everything is local, and that's the thing that makes sense is just execute the local version, which was previously exactly the reverse of what we did. Okay, so there's a lot of room for query optimization, understanding the overhead of the network, trying to understand the amount of data that you have, trying to understand what you have locally cached, trying to understand when it makes sense to actually continue running queries that the user is actually happy with, maybe should remove the limit clauses just for fun. A lot of things we can play. And this is as far as hybrid execution, what we are doing, and I think there's years and years and years of work on it. One thing I think that we want to go, and Yves mentioned it already, we want to offer a service that is the most friendly to you, makes the more uses of the resource that you have, and a laptop is one you already have. Like you pay for, it's typically very beefy machines, a lot of cores, right? So we really try to optimize to say, bring it everything locally, use as little cloud resources as possible. So, with that in mind, well, we do want to offer a cloud service, right? So we can't just say, hey, local and that's great, download data and we're fine. There is a lot of things that go along with people's expectation of what it takes to build a cloud service, and it's a good one, right? And that goes pretty far in terms of complexity. So the first thing we expect from the cloud, like Google Docs and all these services, that we want to work on it together. That's part of the upside. It's very hard to work on a laptop together. If you like pair programming, maybe that's different. But cloud, you expect it, right? So that means that if I want to give you a copy of my data, if data is 20 terabytes, that should be possible and not should be very hard. So now we need to build zero copy function like this. If I want to say, hey, I fucked up my data, I want to go to a version of 10 minutes ago, people expect to be able to do it. I don't think anyone expects to do it on a laptop, okay? Same go if I shared my data and now I changed it and I want the updates to be pushed out, even though I just did a zero copy. And all of this need to be synchronized, and finally you also need to know who you shared the data with and what actually means, and revoke it, and all this administration goes along with it. So we need to build all of that. Then, one of our main features as to why the hell you want to move off your laptop and run something on the cloud is because the data is there, so you need to be able to exit it fastly and cheaply and not pay egress cost But it turns out that's not so easy. And actually, Yonek here, which was a colleague from Elastic, worked a lot of time trying to optimize the speed it takes to pull data from S3. Right? So you need to make sure you're concurrent. You can concurrently read it. You need to make sure that you obey whatever Amazon rules in terms of throttling and spread out the reads. You need to make sure that you even maybe DuckDB runs with 3 threads because that's what makes sense for the planning. We want to read the data with 20 because that's what will saturate the NIC out on the VM, and so forth and so forth and so forth, right? So this is the core feature, and it takes quite some attention. Then finally, one before finally, we have this magic word called serverless, right? So which basically is a synonym to everything should just work and I don't care about anything, right? But cloud is not. You'll see later also, it's just a bunch of machines and you have all these configurations, and below the hood is just Linux with processes and threads, and everything is the same, right? So you need to go and hide all of this and do all the work, and that's exactly why people move to use SaaS offerings, so you don't need to worry about all these things, but it actually is pretty hard, right? So you need to configure the buffer pools to make sure they fit into memory. Out of core functionality was just discussed. That means they need to be automatically tweaked, right? Because people expect the cloud to do anything they want, no matter what the size, and that's obviously not really the case. So we also be resource efficient. We need to make sure that if 2 of you use the cloud service at the same time, so you don't feel like there's 2 of you walking around, and it's fully mined and it works and it's great. Again, reality is very different. And most importantly, for a price, if you want to be really friendly for the cloud, people assume this elasticity, which is typically what people talk about is going up. But going down is just as important. Like if my cloud is not doing anything, I don't want to pay, right? So scaling down to 0 is an important part of it. And then finally, if you want to have an efficient cloud, you need to move things around. It's not like your laptop, which stays your laptop with you. Like I'm married to my laptop and I carry it with me everywhere. That's just not how it works, right? So I need to be able to offload, to move workloads, all of this without people not noticing. And the last challenge we wanted to call out is execution speed of reads, okay? So, but we want to do it from a very cheap storage. Like blob storage, you can store as much data as you want. It doesn't cost anything to anyone, and that's what people do. But it has to be fast, okay? So then again, that tension doesn't really work out, which means we need to look at layered caching of bringing the right data very close to duckling, actually on the same machine, otherwise it won't fly, it needs to be in the memory. On the other hand, people expect to write it, and write it should be persistent, so we now need to go and store it somewhere else. Replicate it, we cannot upload this to S3 because S3 is just too slow, and we need to deal with all these things. What time is it? Again, if you have any questions, just raise your hand and ask questions. For me, it's much more fun. Okay, so what did we end up with? This is actually almost everything is there already. That's our architecture. So first, these are all the places where DuckDB can run embedded. Okay, that we wanted to choose. Again, you have your Python, which was just mentioned, or the modern BI that runs Java, and JDBC, or wherever, right? It doesn't really matter. The way we interface with DuckDB is by loading a MotherDuck extension. Again, you'll see it in a second. And that one hooks into all those beautiful places and try to connect them to their equivalent counterpart in the cloud. Okay? And we also offer a web UI to show it, where you can get very similar experience through Wasm. Think about Jupyter Notebooks or any other BI, just to show and allow people to interact with the data. I think you can all appreciate from GitHub what does it mean to have a UI that's just always there to look at your Git report. Each of those local DuckDB instances, as soon as they connect to the cloud, get a cloud-side DuckDB instance running. We call them ducklings. And I forgot to mention about the serverless section. If you scale down to 0 and you want to run a query, you expect that server to be there. And you expect the server to be there within 20 milliseconds. And even though it's not really there, and if you know a little bit about Kubernetes, it takes 20 to 30 seconds to start a container. So to do all of that, we have also ready-to-go ducklings that people just claim, and now it's there. So we do run right now in one-to-one mapping, which also helps with the isolation. And then you see all the underlying services that are geared toward understanding which database you have, even if Duckling goes away. There's a whole service layer that pulls things from S3, and then that one is still future, and make sure that's ready to go, and so forth and so forth. And long term, we also want to integrate with external database, just like DuckDB can do now. Okay? There. So, yes.
So one thing I was wondering about, suppose you containerize, and like the data it operates on, can you have like multiple containers that operate on the same data set for read at least? Or?
We could, in theory. Okay, the problem comes with the writes. Okay, so right now we walk away from this entire problem and we have one-to-one mapping, and then we use that's one of the discussion we have. But the simple collaborative model is if you want to share data with me, you can create a shell, and that will allow me to open a point-in-time snapshot of your data.
Okay.
And then the collaboration happens on S3 really. That's what it does.
Thank you.
Yeah. Yes.
I don't understand where the data is coming from in this schema. So let's say I have my packet file somewhere.
Yes.
And then I deploy your backlinks, close to my data, and then local DuckDB is gonna talk to them, to process it. So it's like I have my data and then I use this, or it's like I need to bring my data to you
both are an option. Okay, so this S3 actually serves in two roles. You will see later in the demo that we can access any S3 bucket, just like DuckDB can do today. But we have our own buckets that we manage, and all the more fancier features like zero copy and table names and all these things all work on our managed S3 because we actually need to change the storage format of DuckDB to do that.
So this MotherDuck is not something I can install. This is your
this is a SaaS-based offering. Yes.
Okay.
But you can get access to it on any DuckDB you want anywhere. At least that's yeah.
Okay.
And other than that, you can write to your DuckDB client locally. You can do create table as blah 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 blah, and blah 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 as everything that DuckDB can do, and we'll upload the data for you. Yep. Okay, so the last thing, of course, failures. And I don't know when your laptop failed on you, and I'm sorry if that did happen. Last time that happened to me was maybe 6 years ago. Okay, so laptops don't really fail, by and large. Clouds, on the other hand, also don't really fail, but there is a lot of VMs there. So we need to deal with the notion of failure and be much more conscious about it. And because again, there's these magical expectations, which is why people pay money, that this thing never fails, right? And it's not. so we need to deal with it. And again, there's just an endless list of things you need to worry about. These are the more classical. You can think about them, I think, pretty easily yourself. If you have temporary tables in this Duckling and it has cache resolved, and now it died, and it's just gone, right? And people maybe don't know, unless you have experience running on those cloud services, VMs will die, and they will die without telling you. And sometimes it depends on the type of VM that you pay for. It will be more aggressive than less. It's just you have to plan for this, otherwise it just doesn't work. There's no guarantees whatsoever. It's not like a physical machine in your own data centers. Okay, and another big problem that we have to deal with is, as I mentioned, the cache hydration. Like if you want to be fast, then this data needs to be on VM or super accessible to the VM. Now, if the VM where the cache is running on dies, then hydrating 200 gigabytes from S3 takes some time. And if it's 2 terabytes, it takes even longer, right? So that's a big concern. I actually don't know exactly how we're going to solve this one. So if you have ideas, please talk to me. And then finally, when you run in a terminal and you have DuckDB or run in Python post on your DuckDB, and there's always the user driving the infrastructure and typing command, hitting enter and waiting to see what happens. Right? So there is a very convenient channel of telling a user, hey, sorry, this didn't make sense, the file is broken, the CSV, I ran out of memory, everything just happened. And then like the worst that can happen, and it's pretty bad, but again, like, the process dies. Okay, fine. I lost my process, and then go figure out why. But at least it's a very clear communication channel. Now we have this DuckDB sitting there in the cloud, and there's a local DuckDB, and then a file that talk to each other, and they talk to each other synchronously. And as you'll see later, different pieces of the query runs on different moments, and maybe some in the DuckDB server side. Those queries run a parallel execution as well, and one of those threads hit some exception, and all of this need to kind of roll back and get back to user, which turned out to be challenging. So that is the other thing I want to highlight. And finally, sometimes you don't have any error at all, and it looks like an error. Like it is like we're here on hotel Wi-Fi, and we can get disconnected from the cloud, and then we get reconnected. And what you don't want to do is say, oh shit, we lost everything. Let's rehydrate the cache. Let's repopulate the temp table. Let's run all the session and do all this kind of crazy thing, because nothing really happened. The only thing was a blip in the network. So we need to take those into account. Okay, so now just to show you where you are, Yves, oh, floor is yours.
The moment of the demo. So usually demos are you wish for good internet connection. In this case, actually the point is made when the internet connection is somewhat reliable. So let's see. But, yeah, okay. Let's see. Okay, so I'm first gonna query. Yeah, okay. Cool. No, oh, cool. Okay, so I'm gonna first query a small Parquet file and see how that goes locally with stock.db, almost stock.db. So I'm gonna first load the HTTPFS extension because I need that to query S3, and then I'm gonna load the Parquet extension because I need to query the Parquet file. Cool. So the first thing I'm gonna load is, I think, a small version of the PyPy download of DuckDB, just to see how it goes. So it's a bit slow. I think it takes about like 5-10 seconds, but it eventually completes. Okay, cool. So now let's see. We have a dump. I don't know from which date exactly it is, but we have a dump of the Hacker News commands, which I think is 2 gigabytes or 3 gigabytes, something like that. And so let's see how that one flies. In the meantime, let's see what having a duckling in the cloud can give us. So here, what I'm gonna do is I'm gonna say, hey, I want to connect to MotherDuck. Oh, it's making progress here. Of course, my token is not. Okay, cool. Okay. That is okay. No, come on. Let's start again. Okay. You didn't see anything. Okay, I'm using database.
Make it also a bit bigger.
About time is a charm, right? Sweet. Always a good idea to do live demo, right? Oh, it completed on the other side. I thought I would beat it, but. So now let's enable the log. Let's enable the logging, and we also, so it's very nice to have all this like username. What I did was to try to fetch the names in the little CSV file. So let's look at what's here. So I'm not sure about all of them, like maybe this one, but all of the other should be the right one. So now what I'm going to demo is what Boaz talked about is this hybrid query where basically this bulk of it here is remote and you. Oh, sorry.
One question in between.
Yes.
The speed up is really because your data was already in that duckling, right? So it's
not even in the duckling. It was actually scanned in the cloud. It was not even in the duckling. It was because the server was so close to the S3.
Yeah. So you don't even download it. That's really
right.
Okay.
Well, our server downloaded it for you, but it sits on AWS and very close to the box.
Okay.
Yeah, it's better than hotel Wi-Fi.
So now here we can see the results that I did join between the username and this local CSV file. And here we can have a look at something interesting, which is the execution plan. And what we can see here is that basically on one side of the branch, like what I showed, we are reading the CSV locally, and on the other part of the plane, we are downloading from the cloud. So a bit more proof of what we are doing and how the hybrid execution that was executed.
That's a question.
Yes.
With, you could contrive an example where the order that you write SQL in means that you don't have any of the nice parallelization between local and cloud. So how are you changing the kind of, like let's say join reordering, right?
Right.
Earlier. Is there some kind of combination of, okay, this is like the most optimal based on just the data that's there, plus like some graphy stuff where you want to group things in the cloud locally together?
So it's something, as Boaz mentioned, is very much work in progress, and yes, I mean, that's probably years before we're going to nail that down pretty quickly. I'm also pretty convinced that at some point we need the advanced user to have like nodes that they can say, oh, no, I want to pin that locally or remotely, and so there's a long tail of like scenarios, but yeah, I agree with you that. Yes.
So now it's local and cloud, but you could also imagine like between clouds, right? The hybrid scenario.
That would be another. Well, so technically, as Boaz also mentioned, we have one duckling that is, so we have a one-to-one matching between the client and the client that sits on my laptop and the duckling that runs in the Docker container, right? So while this duckling could talk to a different cloud and might incur your egress costs or like performance loss, this is technically possible, right? Eventually, nothing prevents us to indeed like talk to multiple different clouds at the same time from one client.
I think one of the use cases which grows is the CDNs. So they have some compute at the edge, and then you can put the ducklings over there and then ducklings in the backend and have these multiple reduction layers.
Yeah.
And to the other point, I think the majority of our work will be in this type of optimization. And now we're just setting up infrastructure, and that's going to be hopefully done within a few months, a year, or something like this. But then all the rest of the time is doing what you said.
Other questions?
Yeah, so the blocking is basically that the beam contains around, right? Which perform it. Is it a single one, or would you also kind of try to perform a distributed set of those DuckDBs and then try, if data is partitioned, and then try to basically optimize in that form as well?
So as of today, this is a single one per user. So for each session, it's assigned a duckling. Eventually, we might want to go there, but right now the idea is really we want to focus on like this scenarios that fits in memory, and like you can get an instance on Amazon that goes to 24 terabyte of memory. It's pretty expensive, but like you can, and so at this point, network will probably become the issue. So you will have different problems. Right now, we're really focusing, as we said at the beginning, on the like smaller data set and like make this whole experience very nice.
So to just maybe give more context. So one of the things that wasn't on the slide is that Jordan, the CEO, was the head of product for BigQuery. So and he looked at the data people actually analyze, and these are not the the petaflops that they are like things. There's a more reasonable data size is one terabyte is already huge, and a single server on Amazon can do 1 terabyte sneezy.
Okay.
So the question is, and that's the premise of this entire thing, is that you are paying for the overhead of a distributed system and you actually don't really need it. And so we are striving to stay single node offering and push it to the limit. And at some point, yeah, we may fall over the cliff and introduce distribution at all the price that it means. I think it's way more likely we'll have read fan out. So for multiple, just for throughput. So if you have a website that's powered by DuckDB in the backend, and you have thousands of users, that single DuckDB will not fly. Okay, but then it's just a duplicates rather than a fan out distributed read for multiple instances. Each user will get one.
Thank you, everyone. That's one.
One more quick.
The duckling is now running inside a container.
Yeah.
Can it also run in a Lambda function?
Technically, we could, yeah.
Technically it could, but then
It's not-
spin up, spin down costs.
Right.
Like the cache hydration issue, I just and the allocation of the ducting to this machine. So right now we run on Kubernetes because that's the easiest. I think again, if you look at multi-arches that we're on, then we'll probably have to run custom orchestration. And there's some debates if it should stay containers.
If you have any other question, I probably
well,
have
you
time,
wanna-
so if you have any other
you're the
question,
boss,
yeah.
Yeah, let's maybe, you can ask, of course, you
Okay.
can boss later. But
Oh, later. So.
yeah, let's maybe take the next questions offline and then.
Okay, that was one over there.
Where's Pedro?
Pedro is over there.
Yeah, so can you get going?